All right, today we are diving into something that's a huge deal for developers, building truly bulletproof integration tests for our Spring Boot applications. We're talking about making sure that the code that works perfectly on your machine actually works flawlessly in production. Let's get into it.
So, picture this. You run your test suite, and it's just a beautiful sea of green check marks. Everything passes. That feels great, right? But it begs a really important question. Just because all your tiny little unit tests pass, does that mean your application will actually work when all the pieces have to talk to each other? You know, the database, the message queues, other APIs? And often, the answer to that is a pretty scary maybe.
And that maybe, well, that's what leads us straight into the big integration testing headache. This is where we have to leave that clean, safe, isolated world of unit tests and step into the messy, unpredictable real world where all of our services connect. It's absolutely essential, but man, it has historically been a real pain to get right.
Let's just make sure we're super clear on the difference here. On one side, you've got your unit tests. Think of these as your quick, simple sanity checks. They're fast, they're easy, and they're perfect for making sure one single piece of logic does what it's supposed to. But then, on the other side, you have integration tests. They answer the much bigger, much more important question: does the whole system actually work together? They test the connections, the contracts, between your code and everything else out there in the world.
For years, we've tried to deal with this using some pretty painful workarounds. We've used in-memory databases like H2, but let's be honest, they're not real databases and can behave differently than what you use in production. We've tried using shared dev environments, which, oh boy, that's just a nightmare of version conflicts and somebody else's bad data messing up your tests. All of this just leads to flaky tests, a total loss of confidence, and of course, that dreaded phrase, well, it works on my machine.
And this is a brilliant way to think about it. Using a shared database for testing is like trying to build a delicate watch in a messy shared workshop where someone else is welding right next to you. Their mess gets on your project. What you really want is a brand new, perfectly clean, completely disposable workshop for every single task. That way, you get total isolation and perfect repeatable results every time.
So, how do we get that clean workshop? Well, a hero emerges, and its name is Testcontainers. The idea is so simple, but it is absolutely revolutionary. Instead of mocking services or using those messy shared environments, what if we could just spin up the real services, a real Postgres, a real Kafka, inside lightweight, disposable Docker containers just for our tests? So what is it exactly? Well, Testcontainers isn't some brand new testing framework you have to learn from scratch. Nope. It's a library that just plugs right into the tests you're already writing, like JUnit. It basically gives your test code the superpower to control Docker containers, making real, live services a normal part of your testing workflow. And the life cycle is it's beautiful. It's so simple. Your test starts up and says, hey, I need a PostgreSQL database. Testcontainers goes, got it, and fires up a brand new, squeaky clean Postgres container. Then your Spring Boot app connects to it, runs all its logic against the real deal, and as soon as the test is done, poof, Testcontainers completely destroys the container. No manual setup, no messy cleanup, it just works.
Now, behind the scenes, all this magic is managed by this clever little component called Ryuk. You can think of it as the project's janitor. It's always there, making sure that no matter what happens, even if your tests crash and burn, those containers get properly shut down and removed. That keeps your whole system clean.
And this brings us to what is truly a perfect match. I'm talking about Spring Boot and Testcontainers. Spring Boot is all about making developers' lives easier, right? Convention over configuration, and its integration with Testcontainers is one of the best examples of that philosophy in action. It's amazing.
The integration is just so tight. In many cases, all you need to do is add a couple of annotations to your test class, like @testcontainers. Spring Boot's test framework is smart enough to see that annotation and just automatically handle everything for you, starting the containers, configuring them, and shutting them down. It's incredibly elegant. And here's probably the best part. Your actual application code doesn't even know it's in a test. Testcontainers figures out all the dynamic connection details, the random port, the username, the password, and it just feeds them to Spring Boot. Spring Boot then configures your database connection. Your code connects to it just like it would in production, which is exactly what you want for a high-fidelity test.
And the result of all this? Your tests pass, but with a whole new level of confidence. You're not just testing against some cheap imitation anymore. You are testing against the real, actual technology. That gives you a much, much higher degree of certainty that your code is going to work when you ship it.
Okay, so A single database is one thing. That's cool. But what happens when things get more complicated? Modern applications are often these complex constellations of microservices, all talking to each other asynchronously. Can test containers really handle that? Oh, you bet it can.
Let's walk through a pretty real-world flow here. A request comes into our API, our service writes some data to a Postgres database, and at the same time, fires off a message to a Kafka topic. Then, some other worker service out there is listening to that topic, it grabs the message, does some work, and then replies on a different topic. Finally, our original service hears that reply and updates the record in the database. Phew, that's a lot going on, involving both a database and a message broker.
This is where the real power of test containers modules just shines. The community has built these dedicated, super easy-to-use modules for dozens of popular services. Postgres, Kafka, RabbitMQ, you name it. You don't have to be a Docker expert or figure out all the commands and configuration. You just declare what you need, and the module handles the rest.
So for that complex scenario we just talked about, test containers will, for a single integration test, spin up both a real PostgreSQL container and a real Kafka container. It orchestrates the whole thing, letting you verify that your application correctly talks to both systems and can handle that entire asynchronous flow just like it would in a live environment.
Now, getting this level of confidence on your local machine is a huge, huge win. But the ultimate goal here is to automate this guarantee. We want it in our continuous integration and continuous deployment pipeline, our CI/CD pipeline. And we'll use GitHub Actions as our example. A workflow is really just a recipe. It's a simple file you check into your code that tells GitHub what to do when something happens, like when you push new code. It's made up of jobs that run on virtual machines. And those jobs are made up of steps, which are just the individual commands you want to run.
And a typical workflow for a project like ours would look something like this. First, it gets triggered whenever new code is pushed. The first few steps are pretty standard stuff. Check out the code, set up Java, and maybe cache your dependencies to make things run faster next time. But then you get to the most important step, MVN clean verify. That is the exact same command you run on your laptop, and it's going to execute all of our test containers-powered tests right there in the CI runner. And finally, it can upload the test results for you to look at.
And this right here, this is the ultimate payoff. There is zero difference. The very same tests that you wrote and ran on your machine are now the official gatekeepers for your production code. This consistency completely eliminates that "it works on my machine" problem once and for all.
So let's just quickly recap the big points here. First, testing against real services isn't a luxury, it's absolutely crucial. Second, test containers makes this easy by giving us these disposable, managed containers. Third, Spring Boot makes the whole developer experience just incredibly smooth. Fourth, you can tackle really complex, multi-service architectures with this setup. And finally, the whole thing plugs perfectly into modern CI/CD pipelines for total automated confidence.
So we've done it. We've achieved functional correctness. We know our application works. But this just leads to the next level of questions, doesn't it? Does it work well? How does it perform under load? And what happens when one of its dependencies gets slow or just fails completely? Is it resilient? Well, that's a whole other story for another day.